Okay, before we start working through some of the problems on homework 15, I'm just going to quickly review the definition of isosceles triangles and the definition of equilateral triangles, because that's what this homework is on. So this is our new chapter. This is chapter 12. We haven't covered this material in class before, so I'm going to be doing a lot of the homework with you as you watch this video. We're just going to cover the basics of it, and then your teacher next year will cover anything essential that you didn't get this year so that we can make sure you're not behind at all. But you should be fine. This chapter is different. It's geometry, and it is very different from most math. So again, we're just going to cover the very basics of it, and I will be doing a lot of the homework with you because it is different. I want to make sure we aren't too stressed out about it. So, two different types of triangles. First is equilateral. Equilateral triangles are ones where all three sides are the same length. And because all three sides are the same length, all three angles are the same size. And since a triangle is 180 degrees, if we have three angles that are all the same size that have to add up to 180, we can do 180 divided by 3. It means all three angles are 60 degrees. So if I give you an equilateral triangle right here, let's pretend that's equilateral. Sorry, it doesn't look like it. So it's equilateral, and I tell you this side is 5. Then you know this side's 5, and this side's 5. And you know this angle's 60 degrees, this angle's 60 degrees, and this angle's 60 degrees. Okay, the other type of triangle we're going to talk about here is an isosceles triangle. I just had a brain fart and I don't remember how to spell that. Hold on. Yep, definitely spelled that wrong. Okay, that's better. So an isosceles triangle is one where two sides are the same length, but not the third. So two sides, same length. And the base angles are going to be the same size. So the base angles are the ones that are formed with one of the sides that's the same length and the third side that's not the same length. So this is a base angle, and then this angle touches that third side that's not the same length, so it's a base angle. So base angles, I'm going to use this symbol. This symbol is congruent. It means same size. So congruent is like equals, but it's for shapes. And then one other vocab word here. This piece right here on an isosceles triangle, that is called the vertex. The vertex is the angle that's in between the two sides that are the same length. So if I give you, let's keep that, this triangle, and I tell you it's isosceles, and I know two things. I know that this side is 4, and this angle right here is 32 degrees. We can fill in more information from that. Since this angle's 32 degrees, this one's also 32 degrees. And since this length's 4, so is this one. Okay, so number 1 says, using this figure, identify which angles are congruent. So we're told in this figure that line segment AE, so remember the symbol above means line segment. That line segment is congruent to line segment DE. So it's saying we have this big triangle here, it's isosceles, so then our base angles have to be the same as well. And that looks like it is angle A Notice it already has the angle symbol for you, so you just need to drag this up into that. And angle D. And you don't need to say angle EAB on this one because there's only one angle A. Okay, then you need to figure out which one we use. We use the base angle theorem. The base angle theorem is the one that says that if the sides of an equilateral triangle are the same, then so are the base angles. Okay, number 2, very similar, but this time we're told that AB is the same length. Sorry, let me get a thinner pen there. AB is the same length as EB. So we're dealing with this small little triangle, and it's isosceles. Since it's isosceles, its bases are going to be the same, or its base angles are going to be the same. And on this one, this is angle A. Angle A is congruent. So remember that symbol, congruent means same size, just like equals, but for shapes. And then it's congruent to this angle E right here, but angle E could be referring to this one, this one, this one, or even this full thing, or this little part of the thing. So there's a lot of different angle E's. We need to specify which angle E we're talking about. If I trace this angle, I hit angle or B to E to A. So there it is. It also could be AEB, but that's not an option there. And same thing on this one, we use the base angle theorem. Nothing on that page. Okay, this one gives us the angles, and we need to identify the sides that are congruent, so it's the converse. The word converse, it's not talking about shoes. Converse means opposite or backwards. So it's backwards from what we've typically been looking at because we're given the angles, angle D and angle CED are the same. We need to identify the sides that are the same. So if I finish this triangle right here, there's my triangle in red. These are the base angles, so the sides that are the same are the sides that touch just one of those angles. So this one and this one. Looks like that is side EC and side CD. So here's CD and here's EC. It's just backwards, but it's still the same thing. Okay, I'm not going to do this one because it's just like number 3, so you can do that one on your own. Number 6, we are given this triangle here, and we are told that this angle is 60 degrees and this angle is 60 degrees. Anytime you have a triangle that has 2 angles 60 degrees, you know the third has to be 60 degrees because 180 minus the 60 we know, minus the 60 we know is 60 degrees. So what that means is this is an equilateral triangle. And since it's equilateral, all sides are the same length. And we know this side's 16, so I'll let you figure this answer from there. Okay, number 7, this is an equilateral triangle. So if you go back, whoops, right here we wrote something about the angles for an equilateral triangle. All angles are 60 degrees, so it's asking what is this angle? I'll let you figure that out. Okay, number 8 is also an equilateral triangle, and I know that because all 3 sides are the same length. Well, in an equilateral triangle, all of the angles are 60 degrees. So this angle has to be 60 degrees. So do 60 equals 3x. Divide by 3. And that will be your answer right here. And you do not need the degree symbol when you type it in because it already has the degree symbol on it. Number 9 and 10 are more complicated than the last few. So I'm going to do most of this problem with you. Most of both of them. Number 9. Let's just start with what we have. So this is an equilateral, this is an isosceles triangle. This is an equilateral triangle. And this one is an isosceles triangle. Okay, so we have those 3 different triangles. I'm going to draw them out over here. We are asked to identify X and Y. So X is the easy part. That is in the red triangle. The red triangle is an equilateral triangle, so all 3 angles are 60 degrees. So what that means we know is this angle 60 degrees. Okay, the tricky part is identifying Y. So because this blue triangle is an isosceles triangle, we know this angle has to match this angle. And the green triangle and the blue triangle are the same isosceles triangle because they both have single tick marks on it. So that means those lengths are the same for all 4 sides. So then this angle and this angle match this angle and this angle. So I'm going to focus on this line right here formed by the blue angle, the red angle, and the green angle. So let's draw that out. This is 60 degrees. This has to match this. What we know is on a straight line, the full angle has to be 180 degrees. And we already have 60 degrees there. So that leaves us with 120 degrees for these 2 pieces. And those 2 pieces are the same. So we're just going to take 120 and divide it by 2. And, oh, look at that. Looks like these are 60 degrees as well. Okay, so this is 60 degrees. Last step is to say, well, if this angle is 60, then this angle has to be 60 as well because the blue is an isosceles triangle. So whatever this angle is, it has to be this angle as well. So then we get 60 degrees for that. Okay, number 10. Find the values for X and Y. Okay, let's take what we know. This purple one is an isosceles triangle. So this angle and this angle have to be the same. And then this green one, okay, apparently I'm using blue. This one, it doesn't tell us isosceles or equilateral or anything like that. But what it does tell us is this angle right here is 40 degrees. So this top purple angle called the vertex angle is 140 degrees because this is a full line. So that top angle is 140 degrees. That's not what we're looking for though. So let's redraw this purple one. Doesn't look quite accurate, but that's okay. Oops, sorry. Okay. This is 140 degrees. And then this is the same length as that. So this angle has to be the same as this angle. So then we can say, well, 180 minus the 140 we already have leaves us with 40 degrees. So the 2 angles together have to be 40 degrees. If I want one of those angles, I'm going to divide by 2, and I get that this angle is 20 degrees. So 20 degrees, 20 degrees. Okay, there's X. I am not going to give you Y If you want to try solving for it, let me give you some hints here. In this blue triangle, we have this right angle mark, and right angle, that means 90. We already have 20 degrees of that 90, so you can figure this out pretty easy. And then remember, in a full triangle, in that full blue triangle, it's 180 degrees. So if you do 180 minus the 40 we already have, minus whatever you get for this, you'll get y.